So we learned, you know about this radian measure. How do we find the arc length when we have a when the angle is measured in term of radian? If you remember, what we had is, if suppose if this is a section of a circle, okay, of radius r, and if this theta is in radians, then what is this arc length? The arc length will be equal to r theta c, correct? So r theta c is radian. So and then we saw some problems with the clock, minutes and hour hands and all. So instead of going for this man-made clock, let us see about the natural clock. The natural clock is the spin of the earth. Okay, so we will see. So we know earth makes a 360-degree spin. Okay, in how many how much time it will take? 24 hours. Okay, so 24 hours it is going to make a 360-degree spin. So let us see in 1 second what is the angle it makes. Okay, so a 360 degree, and radian if you want to call, it's a 2 pi, correct? So earth is making, so the time and the angle made by the earth we are going to see. So in 24 hours earth makes 2 pi radian, correct? So 24 hours, let us convert it into seconds. So 24 hours means, so 24 into 60 minutes into 60 seconds. Okay, what is the angle it makes? 2 pi radians angle makes. Okay, so how much it is? 3600 into 24. Tell me how much it will come? I guess it's 86400 seconds. Okay, it makes 2 pi radians. Okay, so let us take in 1 second how much the angle, how much the earth is rotated. Okay, let us try to find out. So in 1 second, remember, I am not saying about the angle in that we are not using sexagesimal at all. That's why I am making in radian. Okay, so we will not confuse the minutes and seconds of the sexagesimal. So we will use a circular system that's in radian. So in 1 second, earth spins by how much? By how much angle? 2 pi by 864. Sorry. 2 pi divided by 86400 radians. Okay. Well, let us keep it. Let us keep this as it is. So now, so let us see. Suppose if I draw the earth like this. So if this is the earth, and this is what its axis along which it is spinning. Okay, so let us draw an equatorial circle. This is the circle in the equatorial. Okay, so if you want to draw the back side, so it's better to draw as a dotted line. Okay, this equatorial circle. So what? So this is the center of the circle. Let us assume circle to be a sphere. Okay, so what is the radius of the earth? Let this be RE. Okay, so the radius of the earth, RE, radius of the earth is how much? It is 6,378 kilometer. Okay, so let us say, so this is the radius of the earth, and now the earth is spinning by, so this is the spin. Okay, so let this angle be the 2 pi by 8640. Okay, let me use another color so that, yeah. So let this angle be how much? 2 pi by 86400 radians. Okay, so now you know the radius of the earth, you know the angle, so you can find out what is this distance. Am I right? So the distance moved by the surface of the equatorial, this is the equator. So this is equatorial, right? Because the spin is the equator. So what is the distance moved, the surface, the equatorial surface, in 1 second you will get it. Am I right? Because 1 second this has made up this much angle, so multiplied with this one, so this is going to be, so this distance, let me call it as x. Okay, x will be 2 pi by 86400 radian into Re. Okay, so let us find it out. So x is equal to how much? Tell me. 2 pi by 86400 into Re. Re is how much? 6378 kilometer. I am going to make it in meters. So that is into 1000, correct? Into 1000. Tell me. So
0 will be cancelled.
Yeah, 0 gets cancelled. Yeah, tell me. I'll find it out. Let us use pi equal to 3.14. Tell me how much it will be. This is in meters. Okay. You should get some 400 something.
6378 divided by 8,664 will be 7.381.
Okay, so then you get 2 pi into 7 point.
So 73.81.
Okay, into 10, right? 73.81.
81.
Now tell me how much is this?
463.76.
Correct. So let us 463.76. Okay, let us round it off. So it's approximately going to be 464, okay, meter. Okay, so this distance is how much? So this distance is going to be, 464 meter. So therefore, any point here, okay, what is the velocity at which the point moves? Well, this is the distance traveled in 1 second, correct? So any point on the equator, the speed, I am going to call this as V of Re, let me call it as. Okay, V at, okay, let me know I have not called Re, we will equator. Velocity at the equator will be how much? 464 meter per second, correct? So that is the speed. Now can you think of the speed? 464 meter per second, how fast it is? How fast? You know what is the speed of sound? The speed of sound, Cs, that is equal to 344 meter per second. Okay, so the one who is sitting in the equator, he is moving at a supersonic speed. Okay, so we are spinning. The one who is at the equator, you are going to speed the supersonic speed. That is the one. Okay, so then, but okay, this is true only if you are in the equator. As you go away from the equator, okay, so then the radius is going to be smaller and smaller. Am I right? Okay, so we are in India. We are close to equator. Okay, so even while we are sleeping, we are moving at a supersonic speed. We are very active. So you can always tell your friends that near the polar countries. Okay, see, even while sleeping, I am very active because I am moving at a supersonic speed. Okay, so this is so when you put up these numbers, you really get an alarming number. Because we never realize it, right? So this is what our Earth is spinning so fast. So it takes 24 hours to make a one spin. But compared to the size, when you put that 24 hours, one rotation means in 1 second at the equator it's traveling at a speed of 464 meter per second. That is faster than the velocity of sound, we see it in the medium. Okay? Okay? Good.